This is question 16 from the NSAA 2022 section 2, as well as the ENGAA 2022 section 2. So this diagram shows a circuit that includes two batteries, each with negligible internal resistance. What's the reading on the ammeter? When approaching these circuit questions, it's good to draw a little diagram or story of what's happening. So we have a current coming out here that I'll call I1, and the current coming out here that I'll call I2 from the positive end of each of these batteries. So looking at what happens, I2 will drop some potential across this resistor, at least we assume it will. So it'll drop some potential across this resistor here, and then join up with I1 that's past this ammeter where it's measured, and they join together to make a current I1 plus I2. They then drop some voltage together across that 4 ohm resistor, and then they split to go back into I1 and I2. They split back in this way because we know the current entering the battery must be the same as the current leaving the battery. So it must be I2 that returns back into the circuit to leave the battery, and I1 that goes into this top branch that enters the battery and then leaves from here to then go to their respective negative terminals. So if we draw a loop, I'll call the first one loop 1, this one loop 2. Well, we know from Kirchhoff's voltage law, which is just a conservation of energy law, that the sum of the voltages around the loop must be 0. Because if we start at a certain point and we go around the loop like so, and then end back up at the same point, there must be no change in voltage because we've ended up back at the same point that we started. So if we do some equations for this, we know that we gain 18 volts, and this is in branch 1, and then we drop 4 times I1 plus I2, and then we drop 20 I1. Now looking for the second branch, we have 20 volts gained, and this equals the 8 ohms times the current through it dropped. So that is, again, using V equals IR, so resistance of 8, current going through it is I2. And then another bit of voltage dropped, 4 I1 plus I2. Resistance of 4, total current going through it is I1 plus I2. So voltage dropped is 4 times I1 plus I2. So if you notice, we have two simultaneous equations, and we're trying to solve here for I1, the current going through the ammeter. So we'll want to try and find a way of getting I1 and then getting one of these answers that they've provided here. So if we just expanded these expressions, we would get 18 equals 24 I1 plus 4 I2, and then 20 equals 4 I1 plus 12 I2. Just multiplying one of these equations by the other, well, by a number to make coefficients the same, we want to kind of get rid of I2. So if we multiply by 3, the first equation, we would get 54 equals 72 I1 plus 12 I2. And then we have 20 equals 4 I1 plus 12 I2. If we look at the difference between these two equations, we have 34 volts must equal 72 minus 4, which is 68 times I1. Dividing the two expressions, you get 34 of 68, which is equal to 0.5, as 34 is a half of 68, must be I1. So the current I1 must be 0.5 amps, which is answer E. This was just using the fact of currents going into a junction equal currents going out, and the voltage across a circuit must sum to 0, or voltage gained equals voltage dropped in a circuit. So if you have any questions, please feel free to ask in the comments, or if there's anything that needs clarifying.